Hello, this is Beth Dixon, and I am the Math Lab lady, and you can reach me at beth.dixon@ws.edu. And if it is not the spring of 2020, you can find me on the Morristown campus in room 222 of the Math and Behavioral Social Science building. And we are covering the review for Math 0030. I don't know why it says 1030. It's the Math 0030 final review, and we are doing the last page. So you can use an algebraic method to solve each system of linear equations. And as you look at these linear equations, they are not set up to do with substitution. They are set up to do with elimination. So I am not going to use substitution to do these equations. If your teacher only teaches substitution, then you will probably need to ask your teacher to solve these, because I'm going to use elimination on each of these. So I'm going to do a couple of things. I'm going to get something here so I'm not writing on top of my whiteboard. And let's look at this first equation. So we have 5x minus 6y equals -2. Let me try to keep that straight for you. And 5x plus 5y equals 9. So as I look at this first one, when I do these, I'm trying to decide whether to eliminate the x's or the y's. So I'm looking to see if there's any of these places that share a number. And then if they share more than one number, I'm trying to see about signs. So as I look at these, the first thing I notice is that there's a 5x and a 5x. So that means they share a number, but they don't share a sign. That means if I added them together, 5x and 5x would add to 10. That does not eliminate. My goal is to have either the x's or the y's to be the same number, different signs. So my goal is to have the same number but different signs. Because if I add a positive and a negative of the same number, I get 0. And that's what we mean by eliminate, and therefore the elimination method. We can eliminate one of the variables and then solve. So in this case, my x's are the same number, but they're not different signs. So what I'm going to do is take this top equation, and I'm going to multiply all of that equation by -1. Notice where I put my parentheses around both the entire equation. That then gives me -5x, a -1 times a -6 gives me a positive 6y, and a -1 times a -2 gives me a positive 2. Then as I look at the next part, that gives me, I don't have anything multiplied there, so I'm just going to copy it down. That gives me 5x plus 5y equals 9. Then I'm just going to add the two equations together. At this point, I know whether I've done the first step right if one of the equations eliminates. -5x plus 5x adds to 0. They eliminate. They were the same number but different signs, so they added to 0. 6y plus 5y equals 11y. 9 plus 2 equals 11. Then I'm going to divide both sides by the number left in front of the 11. That lets me solve for y. And now I know that y equals 1. Once I know that y equals 1, I can use either of the equations to solve for the other variable. I know y is 1. Now, in this case, there are lots of reasons to use one equation or the other. I'm going to tell you, unless you have a good reason to use one or the other, just substitute it into the top equation. So I have that top equation, it's 5x minus 6y equals -2, and I'm going to replace the y with its value, which is 1. and then I'm going to multiply 6 times 1, which would give me 6. So that's 5x minus 6 equals -2. Then we're going to look, and we're going to get the x by itself by adding 6 to both sides. That then gives me 5x equals 4. Then we're going to divide by 5, divide by 5. And x equals, now if you did this on the calculator, you would get a decimal, and I kind of like my fractions, so you could use either one. You can either get 0.8. I'll probably leave it as 4/5. And I like to make sure that my answer is written as an ordered pair. And we want to check these, and to check these, it has to make both ordered pairs true. So that's going to be 5 times 4/5 minus 6 times 1, and that should be, I put 5/4. I said 4/5, I think, but I typed down the wrong thing. It didn't give me the right answer. So let's try that again. 5 times 4/5 minus 6 times 1. Did I type it in right that time? 5 times 4/5 minus 6. And it gives me -2. Yes, that does give me the right answer. And 5 times 4/5 plus 5 times 1 equals 9. So that is the correct answer. Okay, let's look at the second problem. I have a 2x and a 4x, a 7y and a 3y. Now the 7 and the 3 are kind of nice because they're opposite signs already. And the 2 and the 4 are nice because they're kind of smaller numbers, but it really doesn't matter which one you eliminate. If I choose to eliminate one, you'll have chosen to eliminate the other. But I'm going to choose to eliminate the 7 and the 3 because they're already opposite signs. So I don't have to worry about my signs. I won't make a sign mistake. And for me, that's where I tended to lose things when I was in math. I would lose my signs. I would have to just double and triple check my signs as I did the problem because that's where I always made my mistake. So if I could avoid doing something that involved the signs, then I would be better off. So I'm going to do this, but what number do 7 and 3 both go into? Well, they don't go into anything other than 21. So in this case, that means the first equation gets multiplied by 7, and the second equation gets multiplied by 3. So that gives me 14x plus, I said that backwards, this top equation gets multiplied by 3. I'm just all over the place. And this bottom equation gets multiplied by 7 because 49 would not be right. And I caught that. Now, let me say that again because I probably confused you, and I apologize. I've been taping a lot of these today. Okay, I want the 7 and the 3 to be the same number. So if I want them to be the same number, I want them to be 21. So what do I multiply 7 by to make it a 21? Not by 7, by 3. So 3 times 7 would be 21. And what do I multiply 3 by? 7, because 7 times 3 is 21. So let's try that again. That's a 3, that's a 7. And so that gives me 3 times 2, which is 6x. 3 times 7 is 21y, and 3 times 6 is 18. Then on the second one, we have 7 times 4, which is 28x. 7 times a -3 is minus 21y equals, oh, that's going to be big. 7 times -22, which I cannot do in my head, would be -155. 4. Just barely enough room to squeeze that in there. Oh, and there's that silly mouse arrow. So what do we have? We have 28 plus 6, 28 plus 6, which is 34. Now, if I had not caught it at that point, I would have caught it at this point because I'd have had 49 plus 9, which would not have been 0. In this case, I caught it before then, and now I have a positive 21 and a negative 21, which do cancel. If you did not choose the right things to multiply by, this is the step it catches it. You want it to cancel or eliminate one set of your variables. And then I have 18 plus a negative 154. Notice it's a plus, or you could say 18 minus 154, but you would not put two negatives there, just the one. And so this gives me negative 136. And then we would divide both sides by 34. And that gives me negative 4. That comes out to be a nice and easy number. We like whole numbers. And again, without anything to say, that then tells us that we're going to put that number in place of the x in the first equation. So that's 2 times that negative 4 plus 7y equals 6. 2 times negative 4 is negative 8 plus 7y equals 6. Add 8, 7y equals 14, divide by 7, y equals 2, and my ordered pair is negative 4, 2. Again, to check, 2 times negative 4 plus 7 times 2. The first one should always check if you've done the second step right. It's the second one that will be the issue. 4 times negative 4 minus 3 times 2. So don't just stop after you do the second one. You want to be sure that you check both problems. And notice I'm just substituting the x and the y here, and I should get the other side of the equation. And that's how you check. Let's look at the next one. 5x and a negative 3y. Those are kind of big. There are opposite signs, but so are the negative 2 and the positive 1. So if I multiplied this bottom equation by 2, I would end up with 5x minus 2y equals negative 7, and negative 6x plus 2y equals 10. Again, you want to think of it as a puzzle. You want to make one of the x, either the x or the y, the same number, but different opposite signs. And you can do that. In this case, look at your y's. This one's a 2. How do we make this one? This one's a negative 2. This one's a positive 1. How do we make it a positive 2? Well, we multiply by 2. Okay, and then we want to add these together. The negative 2 and the positive 2 disappear. Negative 7 plus 10 is 3, and negative 5 plus a negative 6 is a negative 1x. And then we divide by negative 1, and x equals negative 3. Again, without anything to go on, I want to plug it into the top one. So that's 5 times negative 3 for the x minus 2y equals negative 7. That's negative 15 minus 2y equals negative 7. I'm going to add 15 to both sides. Negative 7 plus 15 should be 8. So that's negative 2y equals 8. Divide by negative 2, divide by negative 2. Y equals negative 4, and then my ordered pair would be negative 3, negative 4. Remember, as you write your ordered pair, to put your x first and your y second. Okay, as we look at this, we're up to letter D, 45D, and then as we look at 45D, we have 4x minus 8y equals 24, and 6x minus 12y equals 36. So as we look at the x's and look at the y's, in this case, we don't want to just choose either the, in this case, it doesn't really matter whether we choose our x's and the y's. I'm going to choose the x's because they're a little bit smaller. The 4 and the 6 are smaller than the 8 and the 12. And in this case, I don't want to choose 24. I can do that and make by multiplying one by 4 and the other one by 6. But there's a number that 4 and 6 both go into that's smaller than 24. 4 and 6 can both be made into a 12. You want to think about what can I multiply that they'll both go into. Well, start with 6. Well, 6, I can't make 4 into a 6. I can make 6 into a 12. Can I make 4 into a 12? Yes. So 12 is that smaller number. And so it's kind of like a common denominator, except these aren't denominators. So they're really called the least common multiple. And so we want that multiple that they'll both go into, that common multiple. Now we can use 24, and if you do, it'll work. It'll just be larger numbers, but I'm going to use 12. And how do I make 4 into a 12? Well, I'm multiplying by 3. How do I make 6 into a 12? By multiplying by 2. And one of these needs to be negative, and I'm just going to make the top one negative because it's on top. I mean, really, there's no other reason why. And so what does that give me? That gives me negative 12x, a positive 24y, and I think that should be a negative 72. Let's double check that. Yes, a negative 72. On the bottom, we get 2 times 6, which would be a positive 12x, minus 24y equals a positive 72. Oh my, what happened? The 12x cancels, 24 minus 24 cancels, negative 72 and 72 cancels. Everything cancels. Well, that means there's actually a 0 there. When things cancel in addition, that means they added to 0. Negative 72 plus 72 is 0. And I get a statement that says 0 equals 0. That is a true statement. I write out of room writing the word statement, but that says statement even if you can't read it. It is a true statement. That means whatever makes one of the equation true automatically makes the other statement true. And because it's a true statement, this means there are infinitely many solutions. I don't have to do anything else except figure out how to spell solutions. I don't have to do anything else here other than write that. If I had got a false statement here, then that would have been that these were parallel lines and that they never crossed, and that would be no solutions. So if you get a true statement, that's infinitely many solutions. If you get a false statement, you get no solutions. Okay, let's look at number 46, which says write a system of linear equations that models each statement. So we've got 3 problems we're going to write there. But notice it does not ask you to solve the problem. So I am not going to solve these problems. Now, if we did solve them, they would solve like problems in 45. So if you want to, you could go back and practice them, but it's not necessary. And some of these are much larger numbers and can get kind of complicated as you solve them. Okay, so let's look at letter A. 800 students and parents attend the school play. Students' tickets cost $2 and parents' tickets cost $5. If $2,869 was collected in ticket sales, then how many of each students and parents attended the play? I can tell you that this problem, it will be on your final in some form. It may not be tickets, but it'll be there in some form. I can tell you that if you take Math 1630, that you'll see this type of problem again. I call this a quantity value problem. Because there's two things going on. There's a quantity of tickets, and then there's a value to the tickets. So as we read this problem again, let's read it thinking about the quantity of tickets that there are. 800 students and parents attended the school play. Now notice it tells me to write a system of linear equations. That means we're going to end up with two equations. So one of our equations is going to be about the quantity of tickets, and one is going to be about the value of tickets. So we have, first of all, as we read this, 800 students and parents attended the school play, and student tickets cost and parents tickets cost. So we've got two types of tickets. So let's go on and label our variables. X equals the student tickets, or the number of student tickets. And let's let Y equal the number of parent tickets. Okay, so there we have our two variables. And read that first sentence again. And I've noticed I've read through the problem a couple of times. I've thought about what I'm going to do. And now I want to break it down one sentence at a time. 800 students and parents attended the school play. That's the quantity. So if I have the number of students and I add the number of parents, that should equal the 800 people who attended the play. That's the quantity. Now I'm going to read the next phrase. Students' tickets cost $2. So that means every $2 times X tells me how much I make from the student tickets. And parents' tickets cost $5. So the value of the cost of the parents' tickets is $5 for every parent ticket. And then it tells you that the value that was collected was $2,869. So that means that if I have 2x plus 5y, that will equal $2,869. And there's my two equations. And this will work if you're doing coins. I have 15 coins in my pocket, some nickels, some dimes, and they're worth $2.15. How many of each do I have? And so you put X plus Y. Now don't work that one out because it won't work. I just made it up off the top of my head. But you can do that, and then you can figure out how many dimes and nickels you have. You do the same thing. One of them is the quantity, then one gets the value of a dime and the value of a nickel. You can do this one with, if you mix peanuts and cashews, and peanuts have a value and cashews have a value. You can do these in a lot of, you can do this with investments. One investment's worth 10%, one investment's worth 12%. And how do you mix and match those? You can do this in a lot of different ways. The tickets is the base type problem. So expect to see this problem again. And so study how this one's put together and think about what would change if this number changed, if that number changed. Where would it change in the problem and why? Think through those things as you look at it and as you study this problem. Okay, let's look at letter B. In letter B, Tammy buys supplies for the office each month. In June, she purchased 5 reams of paper and 4 packages of pens for $52.50. In July, she purchased 4 reams of paper and 7 packages of pen for $65.75. Find the cost of a ream of paper and the cost of packages of pens. So because I'm looking for these two things there, that kind of lets me know what my X and Y are. So I'm going to go on and say X equals the cost of the paper and Y equals the cost of the pen. Now I don't use P because P stands for paper and pen. Sometimes I use the variable that they start with. In this case, I'm not going to. Okay, so what do I have? First of all, notice I read through the problem once. Now I'm going to kind of go back in again. Okay, Tammy buys supplies for the office each month. Well, Tammy happens to be our secretary, and I love Tammy, but that doesn't help me solve this problem. So, extraneous information. Second sentence. In June, she purchased. Okay, so I know something. She purchased 5 of the paper and 4 of the pens, and it has a total amount. So I know that she purchased 5 of the paper and 4 of the pens, which is the Y. I want to put P there because I'm used to doing variables with letters other than X and Y. And it cost $52.50. Okay, and I read one sentence and transferred it into an equation. Break it down into smaller bites. Don't try to do it all at once. And now I'm going to read it again to make sure I understood. 5 of the paper plus 4 of the pens for $52.50. Yeah, that's what that says. Okay, now I'm going to read the next sentence. In July, she purchased 4 of the paper. Well, that would change that 5X to 4X. And she bought 7 of the pens. And this time it cost her $65.75. So there's my 2 equations. And again, I could go back over it, 4X plus 7Y equals 65.75 to make sure that I had set it up correctly. Okay, let's look at number C. Now notice I hadn't looked at this review before, so I didn't know that the dime problem was down here at the bottom. So a jar contains 47 coins, all of which are quarters or dimes. The total value of the coins in the jar is $8.30. How many of each type of coin is in the jar? Well, this is the quantity value problem again. Just like I told you to set up this problem. I told you you would see it again. I just didn't realize it was this soon. I literally had not read this problem ahead of time. And so this one works just the same way. We want a quantity and we want the value. And what are we dealing with? They're quarters and dimes. So I'm going to use Q for quarters, which is the number of quarters, and D for the number of dimes. Notice it's the number of these. So a jar contains 47 coins, all of which are quarters and dimes. The total value of the coins in the jar is $8.30. How many of each type of coin is in the jar? So I'm looking for the how many of each. So that would be the number of quarters, the number of dimes. And now we'll take that first phrase. Sometimes it's a sentence, sometimes it's a phrase. So we'll take that first phrase. A jar contains 47 coins. Okay, so then that's the quantity. And how do you find the quantity? You add up the number of one plus the number of the other. So that would be Q plus D equals 47. And yes, you could write that X plus Y equals 47 if you're using X and Y. I just wanted to use Q and D. And they're quarters and dimes. Now, how much is a quarter worth? Well, a quarter is worth 25 cents, so that'd be 25X. A dime is worth 10 cents, so that'd be 0.10Y. And so we've got the 2 values of the 2 numbers. So that's dimes and quarters. And so what do we have next? Okay, next it says the value of the coins is $8.30. So if I have 5 quarters, I'd multiply 5 times 25. If I have X quarters, I'd multiply X times 0.25. That's where I get that. So I don't know how many I have. So I have 25. Oh, it's not X. I'm using Q, and it's not Y. I'm using D. See, I wrote X and Y there, and I went right back to X and Y. So that's 0.25 Q plus 0.10 D equals $8.30. Or if you are using X and Y, that would be 25X plus 0.10Y equals $8.30. Notice that you need to use the decimal there because it is in dollars, and it's not 25, it's 25 cents or 25 hundredths of a dollar. So that does need to be 0.25, which would be your quarters, and 0.10 of your dimes. And so there's your equations. Yay! Folks, I have really worked hard trying to get this to you. I hope this was a help. If you would like some help studying for your final for the 0030 class, please just contact me at beth.dixon@ws.edu. If it is not spring of 2020, you can find me in the math lab, which is located on the Morristown main campus in the Math and Behavioral Social Science building in room 222. If it is spring of 2020, you could reach me on Teams or through my email. I hope this was a help to you, and I hope you do well on your final. Thank you.